This video touches on the uh, rate of change and how it relates to slope. Before we can truly understand rate of change, we really need to talk about what dependent and independent variables are. A dependent variable is going to be a variable that relies on another variable, and the independent variable is pretty much going to be the one that stands alone. So if we look at our dependent variables, those are typically going to be our y's, and our independent variables are going to relate to our x's. To find the rate of change, we're going to basically calculate the change of our dependent variables and put that over our change in independent variables. So if we look at an example, this table shows the cost of mailing a 1-ounce letter in different years. So as you can see, just analyzing this table, the years, as that increases, so does the cost. But we would say that the cost is our dependent variable because it's going to depend on whatever the year is. The cost of mailing this depends on what year it is. So our independent variable then is going to be the year. That tells us that our dependent variable, because that relates to y's, our dependent variable, or these, or the cost, is going to be considered our y's, and this is going to be considered our x's. So if you think of this like a T-chart, it's kind of tipped over on its side, but these are all your x values, these are all your y values. Now to find the rate of change, what we're going to have to do is, because what they're asking for is which interval did the cost increase the greatest. So we're going to find how much did it increase here between 1988 and 1990. And then we're going to find out how much did it increase between 1990 and 1991. Then we're going to find out how much did it increase between 91 and 2004. And then finally 2004 and 2008. I'm going to use these different colors to kind of keep it organized. Let's start with from 1988 to 1990. Now to find the rate of change, remember we have it's going to be the differences in our y's over the differences in our x's. And so if this is our y's, then we're going to have to take the difference of these two, which means subtract. So we're going to take 25 minus 25. Oops. We're going to put that over because that's the difference in our y's. Now we're going to do the x's, which is 1990 minus 1988. Notice how I'm going from the later, or the earlier to the later. We're going from the second column to the first. Now we calculate 25 minus 25 gives us 0. 1990 minus 1988 gets us 2. 0 divided by 2 is 0. So we would say that the rate of change between these two time periods is 0, which makes sense because if you look at the cost doesn't change. There was absolutely no change in cost between those two time periods. Now if we move over to the red one, again we're going to do our y's over our x's. So right now we're going to look at just this, okay? Which means we're going to take 29 minus 25 and put that over 1991 minus 1990. And we get 4 over 1, and 4 divided by 1 is 4. So our rate of change between that time period was 4, which is a pretty good increase. That's a pretty good rate of change. Looking at our next one, again, we're going to put our y's, which is 37 minus 29, over our x's, which is 2004 minus 1991. 37 minus 29 gives us 8. 2004 minus 1991 gives us 13. Divide those two, and you should get 0.61 as our rate of change. So overall, when you see that it increases by 8 during that time period, it gives kind of the illusion that we're going to have a really high rate of change. But the more we start thinking about it, the reason why it's so high is because it's over 13-year time period. Whereas this one increased, right here, increased 4 cents, but only a 1-year time period. So this actually works out to be only 0.61 or 61 cents per year. Whereas in the red, it was $4 per year. Or excuse me, 4 cents per year. So, moving on to the last one, we have 42 minus 37 over 2008 minus 2004. 42 minus 37 is 5 over 4. So our rate of change in that last time period would be 1.25 cents per year. And so pretty decent rate of change, but when we're looking for which one increased at the greatest rate, we would say it was definitely between 1990 and 1991. That would be the time period that gave our greatest rate of change of 4. Now, if we wanted to graph that to show the same thing, we can. Because we know that cost is our y and years are our x's, notice how I've built a table here. And our years are going to be on our x-axis, and our cost will again be on our y-axis. On the years, we want to start with 1988, and then try to go up by the same amounts. Notice how I'm trying to keep these intervals as evenly spaced as possible. So I think we can go up by 2s, get 92, 94, 96, 2000, 98, 2000, 2, 4, 6, 08. That's all we need for that. And then we can start here and go up by 5s. Actually, let me redo it. Try to make them a little bit smaller. That should be it. 5, 15, 20, 25, and then 45. So in 88, it was 25 cents, so we can graph that. In 1990, which would be right here, it was still 25 cents. So you can see that the rate of change between those two is nothing. And then in 91, which would be right in between here, it jumped up to 29 cents, which would be about here. So we have a fairly good rate of change. See the increase of that. And then in 2004, it increased to 37. And this is the one that we were talking about that said it seems like it jumps up a lot, but when we look at compared to how many years it's over and the rate, the steepness of that line, it really is not nearly as steep as this one. And then 2008 was 42, which would be right about here. And you can see that is still steeper than this, not nearly as steep as this point. If we were looking at the steepness in line, of parts of this line, that would be the steepest part of the graph, which would tell us that that is going to be the greatest rate of change. So if we continue that on with slope, you'll see that slope, one way to find slope is a rise over run, which another way to think of that is we're going to figure out like rise on a graph would be going up and down, which is our y-axis. So we're going to be asking ourselves how, if we have a graph with a line going through this, how much is it going up compared to how much is it going over? So if we're comparing up, then that's going to be our y's, because we're going along our y-axis. If we're comparing how much are we going left or right or over, that would be our x's, because it's going along our x-axis. So when we're given a graph like this, what we need to look for is exact intersection points. Like this would be 1, and this would be 1. We're going to use our rise over run method. Rise telling us y's, and run telling us our x's. And to find that slope, then we're going to start. I like to start on the furthest left in, remember we're going up and down first, and we're asking ourselves how many spaces up do we have to go before we get even with that next point. If we go over, it's 1, 2, 3 spaces, so we're going to have to rise 3. Then we're going to have to go over 1 to get finished it off to get to that point. So we're at 3 over 1. We rose 3 and we ran 1, which would mean our slope, or m, would be 3. Looking at another example, again, we want to find these exact intersection points. There's a good exact intersection point, and here's another. When we're finding slope, it's important to show and remind that we have positive and negative directions in our graph. Anytime we're graphing, we're going to the right or up, it's positive, and then to the left or down, it's negative. If we start with this one on the left, and again, we're doing rise over run, we're going to have to actually go down 2 to get even with this one. Since we're going down, that's going to be a negative 2. Then we're going to have to go to the right 1, 2, 3, 4, 5. So we actually find out that our slope of this line would be negative 2/5. Go ahead and use what you've learned to continue. The only thing that we have not talked about would be a slope with this one right here. And go ahead, use your calculator, see what you can find. We'll clarify it more tomorrow. Good luck.